Here's another situation where you might have to figure out what the angle is and where the angle lies on the coordinate plane. So how do you think we should tackle these kinds of problems? We're going to find two possible values for theta using the given information. So if I look at A, what we're going to do is we're going to first draw a coordinate plane, and I'm going to try and make it a little bit straighter than that. And we're going to think about the triangle. So if our theta were in quadrant 1, I believe the sine is positive in quadrant 1, right? Because if we put theta here and we do the opposite over the hypotenuse, those things are both positive. In fact, everything is positive in quadrant 1. But sine is also positive in quadrant 2. So our angle could be this angle that is a result from rotating all the way into quadrant 2, because we would get a positive opposite and a positive hypotenuse here. So that's another possibility. So let's think about what happens if this is what our two possible angles are. All right, so the first thing we're going to do is we're going to put the values where they belong. So I'm going to put 2 square roots of 11 over 11. 2 square roots of 11 goes on the opposite. This would be our opposite. And our hypotenuse would be 11. Okay, so if we want to figure out what the angle is, we can take the inverse sine to get rid of the sine. So we know that if sine theta equals 2 square roots of 11 over 11, if we apply the inverse sine to that, that's going to leave us with theta equals the sine inverse of 2 square roots of 11 over 11. And again, this is where you need to get your calculator out and you want to see what happens when you do this. When you do this in your calculator, you get theta equals 37.086. We'll just say 0.1 to keep it simple. All right, this is our theta. So that could be this first angle that we've identified right here. So theta could equal 37.1, but that could also be the reference angle or the gap here that's missing as we travel all the way from our positive x-axis to this terminal side of our angle. So theta could also be 180 degrees minus this gap right here. So if we find our other possible value, which is this angle right here, we would do 180 minus our 37.1, which in this case is the reference angle or the gap, and that would result in 142.9 degrees. So that's our other option for theta. So if theta is in quadrant 1, we're going to get this 37.1 degrees, but if theta is in quadrant 2, we're going to get 142.9 degrees. These take some practice, so make sure you're working together with your group, talk about this, and remember, the textbook is online. If you go into Schoology, you can look at the textbook, Chapter 13 in our whole textbook. All right, I hope this helped.